which is Devise electronics. So let's move ahead and talk with Shekhar more onto this, which may help you to know more about EV industry. So Shekhar, can we have talk with students?
Yes, thanks for. Can you hear me clearly?
Prem, are we able to hear Shekhar? I think there's some
Yeah,
discontinuity in audio.
yes,
Yeah.
now,
Yeah.
Yeah, Shekhar, we are able to see your presentation.
Dhiraj, you able to hear me?
sir, your voice is
I'm
breaking.
able to hear you. Shekhar, there's a connectivity issue, I think, but yes,
Yeah.
your audible was clearly. Yeah.
Me know if so good morning and thanks the opportunity. I'm going to talk about career paths the electric vehicle industry, and I'm also sharing my journey as a
I think there is some audio issue I'm experiencing. Try to change my network.
Yeah, Shekhar, actually we are unable to hear you. So this connectivity issue, we are trying to resolve it.
Hello, sir. So you can talk by switch off your camera. So
Yeah, Shekhar, if you want, you can just have an
turn
audio
on yeah.
connection. Yeah.
Is it better now?
Yes, sir. Yes.
Okay. So we'll start. Apologize for these issues. Hopefully, you're now able to see the screen.
Yes.
Okay, so we are going to talk a lot about career paths in the electric vehicle industry, and also I'll share a lot more about my own journey. And to begin with, I thank IEEE for this opportunity and for Dhiraj to reaching out on this subject along with Bhaskar. And hopefully we'll have some clarity on what is the way forward and what are the unique elements coming in. Dhiraj, can you mute yourself? So introductions first. I'm currently the founder and director of Devise Electronics Private Limited, which was started in 2013. Initially started as a proprietorship, and then it has evolved over time into a private limited. Current organization strength is 38 full-time employees. Our key offerings is in the R&D services, technical consulting, market representation and training. We are significantly active in the electric vehicle industry, though that is not the limiting factor. We do work in non-automotive areas as well. Key areas of operation are automotive electronics, which is also coming with my background. Electric vehicles, that was something that we obviously did not have the background. The first 15 years of my career, I was nowhere close to the electric vehicles. And it's only when this concept and this first vehicle started making inroads. Over the last 5 years, we have been significantly working on the electric vehicle side, and we'll have a lot of discussion about it as we go along during this talk. Then embedded systems, that is a critical area. As you see, our name is Devise Electronics. We do work in the embedded systems area, hardware, software, the IoT enablement, also modeling and simulation, especially with Simulink. Apart from that, we have two standalone brands at Devise. One is called Gyaniki, which we recently started in 2020. And Gyaniki is a online knowledge platform for the new areas of mobility. So when we talk about the new areas of mobility, a lot of times people confuse mobility with passenger cars or with two-wheelers. Mobility is a word which covers a lot of things beyond just passenger cars that are on the streets of the cities. Mobility also includes the warehouse, moving goods from one place to the other in the warehouse. Mobility also includes drones, which are now getting used for point-to-point delivery. And we cover all of these areas of mobility as a knowledge base with complete information on this platform. Secondly, we also have another focus area, which is Prakalp. And Prakalp is working on project-based internships, trying to bridge the gap between the academia and the industry. I would not say that we are successful. I would just say that we have a roadmap. We solve the situation or the problem for both the student as well as the industry, and to some extent for the institute as well. But that is something that we have been using at least for our hiring as well, and working with more better internship programs, which ultimately lead to a job. And that is what the key target is. I would say today we are only 10% successful on that front, but that's the goal in which we are building that up, tying the student to a job in a much not after graduation. In the second year or third year itself, you kind of have a job in hand, you have a roadmap in hand, and you can work towards that. So that is what we are trying to achieve. I also have a couple of other associations, a couple of other companies where I am a director, and they are in different modes, really interacting with the colleges or with automotive electronics. So today concentrating on what we are doing at Devise and also sharing my journey. Please, as you see any questions, please put it in the chat window so that we can go back on those and we can look at those. The idea here is to share at a very heart-to-heart level, and there's nothing really that I have to hide. So that is the key element. So I'll start with some of my background, right, and talk about my educational timeline. So I started with, I hail from Nagpur and did my SSC or 10th from a Catholic school, St. Francis de Sales High Secondary School in Nagpur. Then went on to do the 11th and 12th again with Maharashtra board from a science college in Nagpur. And then there was a decision-making point, right? Obviously, all of you know how 11th and 12th are. You're just running from one tuition class to other class. When I was there was something called as PCM and PCB, right? I don't know how many of you are aware of those terms, but PCM was basically the intent in life was to score good in physics, chemistry, and maths, and rest everything was just let's just pass and clear it, right? And the other was the PCB. I had the benefit of dropping the biology and taking up electronics as a elective, and that really helped me get some insights with all the electronic components, get some interest, do projects on a hands-on basis. So a lot of things that are typically something that you only learn in BE electronics get preponed when there's an opportunity to take the electronics elective in 11th, 12th. And that helped, and post that there was a decision making, right? There was part of me that wanted to come out of Nagpur, move out of Nagpur and go and get into a college in Pune. Pune is kind of the destination for most of people who come from Nagpur, Vidarbha, and the east of Maharashtra. And at that time, Pune was a destination well known, a lot of young crowd, very good colleges known for the education. And but there was a very computer-based system of admission, wherein we had to just fill the choices, and we don't know whether we get into them or not. However, before filling the choices, what my dad made me do is both of us, he and me, came to Pune and we visited all the colleges. Right now, some of you may be in Pune, and at that time, MIT Kothurud campus used to be considered out of the city. It was like, who goes and takes admission there? It is out of the city. And VIT and Bharati Vidyapeeth, these were like jungle areas, right? That was the consideration. Obviously, all of that has changed over time. So there was one part which wanted to go to Pune and live in a boarding and pursue engineering from the colleges here. But I was very, very sure I only wanted one stream, that is electronics. Okay. And the other part was to stay in the hometown, have the luxury of contributing time in my family business, which was also related to automotive. And the choices I did put a lot of choices from Pune. Unfortunately, did not get the admission, and I joined the BE Electronics course and from Ramdev Baba Kamla Nehru Engineering College in Nagpur, which is a fairly well-rated college, very good staff, good infrastructure, and that helped the 4-year journey, along with contributing as an intern in the family business, learning things over there as well. But the roadmap for me was very clear. I always knew what I wanted to do in those 4 years and what I wanted to do after that. And from the 3rd year itself, the preparations were there to apply for masters, and I applied for masters to multiple colleges and joined University of Southern California, USC, in Los Angeles. So the first move in terms of education, the first move was directly from Nagpur to Los Angeles. Right, so there I completed my master's in electrical engineering with specialization in control systems. So that's the journey that it took. I wanted to finish all the education before starting a job. That was another motive of doing BE and MS back to back, and then starting a job. Right, so obviously there were some very crazy days in the job hunt. The job market in the US was not very good, not as dangerous as what it is right now, but it was tough to get a job, and very tough to get a job in the core industry. So there were, in my specialization, in my classes, there were only 10 to 12 people. Not like hundreds of students taking those courses. I was not doing VLSI, I was not doing computer science, not doing computer network. Those were the main skills. Those were the places where everyone was going. But I chose to be different, looking at the interest in the automotive electronics area. And the only way to get there was to go through control systems. And I started in 2005 with Cummins Incorporated in a completely different part of US, from California, going to this state in the Midwest of US. Very different culture, very different type of people, but a very good organization to work with. Cummins making diesel engines, and there I got a job as a diagnostics development engineer. And believe me, had it not been for my base knowledge of automotive, which came from the family business, or which came from the interest, a personal interest, it wouldn't have happened. Right, and the personal interest also included watching Formula One. Right, so obviously back in the Schumacher days, that is what we used to do. And the first roles included development of diagnostics for the diesel engines and the emission control systems, which were meeting the latest emission norms, taking out the nitrogen oxides, taking out the black smoke coming out of the vehicles, and making sure that those systems are working. So we spent a lot of time on field tests on the vehicles, repairing the vehicles, looking at data coming from the vehicles, and also spent a lot of time with the mechanics who were servicing the vehicle, what better we could do for them. And Cummins, we had an electronic service tool, laptop-based service tool, which would give special tests and sequences that the mechanic could run to find the problem, resolve that, and that was my core area of work for the first 2 years, to develop the latest diagnostics that were required. And at that time, there was some regulatory element that was also in the picture called as on-board diagnostics. And this OBD was very, very critical to meet, because if you fail to meet, you cannot launch the vehicle. So a lot of the contribution went in that as well. After that role, typically 2 years, once I had settled in the industry, again, my thought was always to come back to India, but I took another role up as a systems engineer, working on one of the vehicle that Cummins was making for Fiat Chrysler and for Nissan. And there again, now working not only at diagnostic algorithm, but vehicle level algorithms, or developing them, testing and validating them. Even back in the days in 2005 and 2007, most of the software coding work, Cummins did not used to do it in-house. I would say 70–80% of the software coding work used to go to a company called as KPIT Cummins. Now it is KPIT Technologies, and they were a service provider for Cummins. So even though I had a lot of knowledge at the system level, I have never written a piece of code which has gone into a vehicle. I have designed algorithms that have gone into vehicles, but the coding is not mine. The coding used to be done by this offshore team, so there was always a gap in the knowledge, right? Because my work would finish at the flow chart or at the documenting the requirements and then testing what was given back. So that was there. And then, as I said, I always wanted to move back to India, and then came to India with as an application engineer, again with a division of Cummins. Cummins emission solutions. And in India at that time, we were launching the BS4 emission systems. BS4 emission roadmap was there, and in 13 cities, it had to be implemented from 1st April 2010. So the first vehicle, first truck from Tata Motors, which was certified to meet the BS4 standard, that complete emission solution work was done by our team at Cummins Emission Solutions. So Cummins Emission Solutions was providing the emission reduction solution to Cummins engine and to Tata Motors. And that is the work which I did. So there was a big hit in the salary, in the role type coming from US into India. Took it and grew very fast in India, because the knowledge and the drive and the energy was significant. So quickly moved on from application engineer to a technical team leader to a assistant chief engineer, handling multiple applications. And the team at Cummins Emission Solutions grew from a 6-member team to a 100-member team in that duration. So within 2 years, going from 6 to 100. And in 2012 is when I thought that there was no further roadmap. There was no plans of India going to BS5, BS6. And I had worked enough with Tata Motors, Ashok Leyland, Volvo Eicher, all these companies, and exactly knew what kind of gaps are there in the industry. And that understanding gave me an idea that a company giving services, critical services in the application or in the automotive electronics domain, has a lot of potential. And I knew that that was the calling for me. And 2013, I left Cummins and started Devise Electronics. So initially started Devise Engineering Services as an independent consultant. The initial customers were all suppliers that had known me during the Cummins days, and started initial projects with that. Then some people in the network helped get more projects. And considerably moving on, 2-member team, 8-member team, started getting into electric vehicle. We became a distributor of a company making battery management system, which is a critical part of the electric vehicle. And so on. Today we are a 38-member team. We have survived, sustained, and surged under the COVID. And we have also launched our initiatives like Prakalp and Yaniki. There is a startup which has completely incubated at Devise and is running as a separate company by itself. So those are the key elements of the journey over the last 7 years, and the growth continues.
Shekhar,
Yeah.
yeah, Shekhar, yeah, just a query. Like you said,
Yes.
OBD, when Tata was first to launch OBD with their truck.
Yes.
And also you said that when you were working with Cummins, software part was not taken care by them. I mean, what was the main reason, or what was the main thing that basically was not letting them?
Right. The key element was that software engineers in India were much cheaper. And it was very easy for the company to still own all the technology, all the algorithms, and just send the conversion of the flow chart into a embedded C code or into a Simulink model, get it done from a service provider outside. Okay, so it was more of cost efficiency for the company. But that software engineer doesn't know how these things work on the vehicle, right? So they just convert it into code, give it back for testing. And again, it was tested by the same engineer or the same team that gave the requirement.
Okay, so for long run of the organization, there was no much impact. I mean, on this particular development, right?
Right, right.
Okay.
In fact, that's how all organizations are working with their extended tech centers in India. Be it John Deere, be it Bosch, be it Mercedes Benz. So I would say Cummins was someone who started offshoring of work much earlier than anyone else, much earlier.
Okay.
Right. So today, as we said, we are a 38-member team. We have survived the COVID and ready to continue the growth. So what are the choices, right? Obviously, as a startup, we do get investors who become excited about us, but we are not a product company, and everyone wants to invest in a product company. We are in a R&D services company. We work with all the OEMs, all the tier ones, do bits and pieces that will help them launch their product in the quickest way, right? And we are in a niche segment. We do not have a competitor. Our largest competitors are 100 times larger than us, so they don't view us as a competitor. There is a immense room to grow, and no one new enters this area, because every project for us is a new headache. It's coming with unknowns. There is not a simple project that comes to us. If it's already done and known how to do, we don't get those projects, and we don't want to get those projects. There are other companies who can do drawing updates and do those basic elements. We are always looking for where the largest unknown is, where we can bring value. So our path is to continue to grow with or without the external support, and that is how we are moving ahead. right? So I will now switch some gears, and I want to talk about what really motivates an engineer, right? So even back in 2003, if I would ask my classmates to say why they are pursuing engineering, there would be answers like पेरेंट्स ने बोला है यही करना है, सब दोस्त कर रहे हैं तो मैं भी कर लिया, या डिग्री चाहिए बस, डिग्री के लिए तो करना ही पड़ेगा, or the only motive is to get a salaried position. And all these are the worst thing to get into engineering. And then if you are into engineering and if you fail a couple of papers and you have to repeat those papers and get a backlog, it's a nightmare. So if anyone is doing engineering for these reasons of parents said so, or peer pressure, or just for the heck of the degree, or just to get a salaried position, I think they need to go and discuss with the parents, brainstorm with the friends. They are wasting their time. There are much valuable things which will pay much more that they can do. Right? Because if the creative energy and the passion is not aligned to the field, there is no use. Right? Actually, engineers during that 4 years, when they end up with a question saying, what kind of job I should get, that question itself is completely wrong question. In fact, they should have known by now what exact stream that they want to work in, what piece of it, what focus of it, and then know what are the 20 companies or 30 companies that are doing that kind of work, and be focused with them, right? But that's not how we work. We finish these 4 and then the job question, 4 years, after 4 years, the job question mark comes into the mind. So unless you are in the engineering, unless you are pursuing BE or you have pursued BE already, unless it was done with the need to engage passion or energy or get creativity, to innovate, to collaborate, to develop, to implement, to apply, to solve, to invent, to learn, to teach. If none of those apply, it's totally a mismatch, right? And the ones which apply, then you have to grow on them. Why did you join engineering? Why do you think you are doing engineering? What's your end goal? The end goal could be to teach or become a lifelong learner. Now there are many people who just do that, or to apply, or to make something, right? What is that motive? That motive has to be very clear. Unless you make that motive clear, trying to get a job or thinking of a domain like electric vehicle, that is just not going to make any sense whatsoever. Okay. So this is something that I was discussing with one of the incubation centers that we are actively working with, and this was their list. Okay, this is their study over 15 years of working with engineering students, and this is the list of priority in the mind of the student. I want to get a job. That is, most of the people want that. Then a lot of students have just pursued engineering because that's the easiest path to get into civil services and appear for the UPSC. A lot, right? And if they know that, then that's good. But if they don't know that, or if they if they don't make it known to everyone, then they are not going to get there. Or get into Masters of Engineering programs in India, postgraduate programs, pursue postgraduate from abroad, USA, Germany, UK, Australia, or divert into the MBA side of streams. So these are the top 5, and on the least priority. So in a class of 100, and if we remove the people who already come from business families, there will be only 1 or 2 that will say entrepreneurship is their choice. And that is something that we are also trying to say is, no, now there are enough success stories. That should not be in the bottom. That can also go higher. However, the key element is how soon you decide. How soon you decide makes the most difference. And once you decide, you apply the incredible Fevicol, right? So Fevicol is, I would say, the most important ingredient of a solid career. There are so many people, they take offer letters from 3 companies. And the final motivation is based on salary, not on what they want to do, not on what the company is doing. And there is no Fevicol, right? Next day, someone else gives a better offer, they'll move. So unless we apply the Fevicol, unless we stick to the decision, unless we stick to the plan that we create, there is no proper career that can be made, right? So these are the paths available at graduation. My personal interest has always been in making the entrepreneurship move higher, because people do want to do that. And after 10 years of job, when they try to do that, they don't have the courage. They don't have the courage. They don't have the necessary thought process on how to go about it. They struggle. And then they feel that they should have done it before, right? And even the financial risk is significant after 10 years. The financial risk of doing it and failing at it right after graduation is very low. Now, if you are looking for choosing the right company, and it doesn't matter what domain, maybe electric vehicle, may not be electric vehicle, there has to be a match. So if you are a self-starter and self-motivated person, then you should go look out for the startups making products, or even the large product-focused companies. Because if you are self-motivated, you will be able to grow further. A startup needs both self-starter and a self-motivated. There is no one who's going to train you for 1 month or 3 months. They don't have time. They don't have patience. They want someone who can understand and also know what is the skill gap and work on that skill gap along with doing the work itself. So self-starter and self-motivated, continue doing that, even maybe sometimes at lower salaries than what their friends may be getting for doing nothing at other companies. And if you're not a self-starter, if you're not self-motivated, the only motivation is the salary and the paycheck, just look for an engineering services one, the non-innovative company, which is just getting a drawing, doing some analysis and sending it back, doing the same thing for 1 year, 2 year, 3 year, or work at a back-end captive engineering center where you can do everything but not use your brain, because the brain is sitting somewhere in Germany or US. You will get the work, you will learn a lot, but you will not be required to use your brain. And if you are happy with that, then that's the best solution. It pays well. So you have to match up. The electric vehicle industry is full of startups, or even the bigger companies, their electric vehicle divisions are literally working as a startup. So unless you are a self-starter and a self-motivated person, there is no benefit whatsoever in looking at electric vehicle industry. It's not going to be fun, right? And if you are having a bunch of ideas yourself, then, as I said, take the risk, talk with the incubation centers. They will take interest, because right now these incubation centers are well funded. They have a lot of infrastructure. They have the supply. They don't have the demand, and they are unable to find the right people or the right students who are ready to take the risk on their ideas. A lot of people, even with 2 years of industry experience, have left the industry and gone to an incubation center, and they are working with a team on their ideas and progressing. So that is something that should be considered. And especially if it's related to the electric vehicle domain, there is a lot of new things happening. Right. So a question maybe is, can this be planned? Can a roadmap be planned? Will it work? I think the will it work comes secondary. First of all, is there a plan? Is there a roadmap in your mind? How you want to progress? Let's say electric vehicle industry, how do you want to make the breakthrough? What skills do you have that will enable you to make the breakthrough? Right? Obviously, the industries evolve. When I was in engineering, there was no question, no one looking and talking about electric vehicles. Even when we formed Devise Electronics, there was no one thinking and talking about electric vehicles. It was like a side project for some companies. And obviously, a visionary person changed that, and all of you know that. Today, the impetus or the focus that the electric vehicle industry has obtained, a significant contribution of that is from Elon Musk. Significant. It's incomparable. No one has made an industry shift like he has. Right? Obviously, there is climate change pressure, and the companies were being forced to reduce emission and look for hybrid and electric. But the success of the product was demonstrated only by one person. Take it out into the market without any support of the traditional industry. Right? So obviously he had some plans, right? And part of it did not work. A lot of things got delayed. But if you have a plan, if you stick to it with Fevicol, that is the benefit then, right? And similarly, when I was in 11th, I made a plan that I will pursue master's education from abroad. Kind of worked on a five-year plan, then another 5-year plan. I wanted to come back to India and be able to start something on my own by 2010. And that did not happen. Did come back to India in 2010. But making or starting something on the own, I was still not ready. I wanted to understand the Indian market much better. And that work that the company was having openings. And all throughout, I made my company aware that I'm only going to be here for 3 years or 2 years or 1 year or 6 months and 3 months. And so they were fully aware that I am not intending to stay longer. So make the plan and share the plan with others. your key stakeholders, your friends, maybe your boss. And that works. That works. If you don't share it, then it won't work. If you share it, it will work. And it took courage, right? When starting a new company, it took courage. Even the name, I thought a lot about what it should be called. What name? What am I trying to achieve? What are we going to have as a vision? Right? And we purposefully chose this word, devise. And a lot of people still confuse it with device. And it's totally different things. But since we are in the electronics domain, we get confused, and people still, in most of our emails, we get referred to as device with a C. But still we end up delivering our output as a device with a S. We take up what needs a solution. We love brainstorming and ideating. We love analysis and equally value the trial and error. We work to solve the challenge. We devise, right? So what we do is in our name. What we do is in our name, and we are always looking to get onto something new, something which others feel is a headache or which is a roadblock. And that is where our team has grown. Individual members have grown at Devise, but it's not everyone's cup of tea. If someone wants a very defined job work or a job role, we don't have it. So if someone says, if I say I want to hire an engineer with 3 to 5 years experience, and someone says, what is the job description? It is doing engineering. Being able to, what is an engineer? An engineer is someone who's able to understand the technicality and work on it. The domain doesn't really matter a lot. The domain can be very easily understood. But there are now engineers who say, I only want to do X and I don't want to touch anything else. And they are good for some other type of companies, don't get me wrong. And focus is always good. But that doesn't work with a small company and with a startup. The same engineer has to make a wiring harness, has to do a lot of menial work as well, and also work on the most strategic project. That is how a startup works, right? So our initial tagline was the free electron, wherein obviously from physics you may remember free electrons. And what it meant to say was we are energized, we are self-motivated, and you can apply our strengths in any direction, any field, right? We are ready to contribute. So that is what we had started with as a tagline. Obviously, someone who doesn't remember physics, it was very tough for them to understand. They felt like we are giving services for free. I said, no, we are not giving services for free. We are a free electron, right? You have to input the energy and we will contribute, but you have to input the energy. So our tagline, later we evolved that to persistently exciting, which is another term coming from the control systems theory. And it's a very, very beautiful term. And that is what keeps us going day along day. Every day is a new challenge. Like in most of the electric vehicle industry, there is a new challenge, a new problem that we have to cater to every day. And that is where the focus remains for us. That is the type of engineer we want, who's ready to wake up and wake up to a new problem, to a new question, research the background, look at options, try to implement some trial and error with some risk, understand how to use the right tools which are going to help select a solution, implement the solution, be able to test it out, be able to validate it, and confidently talk to the customer and take it into the final release state. So that is what it takes. It doesn't matter where the core skill is. It doesn't matter whether the core skill is civil engineering or industrial engineering or mechanical engineering. In fact, we have had over the past 4 years, we have had multiple engineers who had a background from mechanical engineering, and they were able to contribute significantly well in the overall electronics. In fact, one of the recent ones who was working as a chief engineer, now he has got a role in a company primarily based on his electronic skills or electronics integration skills. So, but his original element was mechanical. So we see that today everyone in the engineering world or the academia world seem to be still divided between mechanical and industrial and computer science and electronics. Within electronics, the ENTC feels differently, the pure electronics is different. Then computer, there are different branches. Now there are data science elements coming and this and that. That is not the output that the startups want. Startups want an electronics engineer who doesn't shy from getting the hands dirty, or a mechanical engineer who doesn't mind soldering. Right? So those are the type of people that the industry wants, and unfortunately, that's the output which is not really coming. And most of the engineers seems to have a roadblock saying that they only want to do X. Obviously, there are streams that pay well when you attach the data analytics and the computer science and machine learning and some of these buzzwords, they pay well. There are some industries which people just don't understand completely, where it's the IoT and all the integrations that come with it. Still, someone putting IoT engineer, they don't actually know what is the overall ecosystem. And those are the challenges that the industry is facing. Most of the vibrant startups in the electric vehicle area, they are working with teams of 20 to 50 people max. And these members of the team are working in multiple areas, contributing in wearing multiple hats, contributing in multiple ways, some of them also contributing in non-technical areas. That is not everyone comfort zone. So for us and startups like us and smaller companies like us, selecting the right candidate is very, very challenging. And right now the demand and supply is totally lopsided. There are so many experienced people from the traditional industry who have lost jobs. There are so many newcomers who have got trained over the lockdown period in different aspects of the electric mobility by means of multiple online classes. And there are people who are going to graduate next year. And all this is very complicated. The demand and supply is totally lopsided. There is a lot of supply and there is very little demand from the industry right now because everyone is saving cash because of this year's issues. And unless you differentiate, unless you become visible in more ways than one, getting a job is challenging. Even though this electric vehicle field is going to significantly scale up. Right now, there are talks about setting up so many charging stations. There is talk about so many applications and new vehicles coming up. Just yesterday, a company called as Pravek Dynamics. They launched their vehicle. It's a four-wheeler. They have been touted to be like the Tesla of India. They are working in a very different segment, a cab, luxury cab vehicle, not a personal vehicle, a cab vehicle, but a luxury one, wherein you can sit comfortably and do all your meetings from the car itself. That kind of vehicle they are designing, and it's a completely electric vehicle, and they are the only startups in the four-wheeler domain who have reached this level of having a launch event in India, and a totally Indian built, Indian thought process kind of element has been there. So you can look more about them, Pravek Dynamics. Yeah, Dhiraj?
Shikhar,
Yes.
like you talked on the startups, basically the engineers who are in startup, they play a multidisciplinary role there.
Yes.
What you think, Shikhar, that is very important as a student to work on this diverse skill? What should be
Yes.
developed for as a student? Yeah.
Right. So, so how to be ready, right? Dhiraj, to your question, people will need a solid depth, but more importantly, they need a wide breadth. The breadth of the knowledge has to be very wide as well. You cannot just stop between hardware and mechanical and IoT and data science. Now, when it comes to the depth, people have to understand the skills which are required. So there are some skills which are now much more favored in the automotive domain above the others, where there is significant requirement. I've captured some of them. I'll talk about. So when it comes to embedded hardware, right? Previously, no one was making controllers and embedded hardware in India. It was all coming from China. And right now there is a lot of push to move things away from China. So companies are making their own devices, IoT devices, own body controllers, own vehicle controllers. And for that, there is a strong requirement of embedded hardware skills, even battery management systems. So a lot of elements are there related to the embedded hardware. Literally every component, every major component in the electric vehicle is going to need a lot of work on the embedded hardware. Motor control unit, battery management system, vehicle controllers, IoT and telematics devices, right? And a lot of this work is now happening in India, for India, right? Then we have embedded software. In embedded software, we have key elements of embedded C, then Simulink or model-based generation of the software. Also the architecture in terms of AUTOSAR. These are skills that are required, and some of these are not in the curriculum. Or Simulink, even if the usage is there, it's probably MATLAB Simulink will be on everyone's resume, but the depth of it is not there. Even though students get a complete license of all the all the Simulink libraries, the utilization that they do over time is very, very low. So unless you show your work, unless you are able to show how you are making something, and today a lot of resources are available online to be able to do your own open source development, but that motivation has to be there, right? Now, while someone is doing this, a hardware person also needs to understand software to some level. May not write the most efficient code, but be able to work the hardware they are making. So at least know enough on how to actuate the hardware. Similarly, the software person needs to know how to attach the hardware and make it rotate, right? And sometimes this is not going to be a 12-volt play. We are going to go with significantly high voltages, and there the power electronics becomes very important, and it is a very risky element. Lot of things have to be considered. If you are not following the rules of development, then these devices won't work, they will fail, they may burn, and that is where the knowledge of high voltage electrical system and the power electronics is very, very critical. Be it the motor design, be it the inverter, be it converters, DC-DC converter, be it the electric vehicle charger, all of these points are coming into the equation. Then there is battery integration domain, which is going to become one of the largest domains in India within the electric vehicle, because now there is a demand from the government that everyone uses localized battery packs, and even try to get to localized cells in the near future. And with that, there is a lot of industries which are now setting up in order to make lithium or high power density cells in India. And then the complete integration into the pack, integration with the battery management system, integration with the IoT devices, all of that is going to be required, right? So at least these awareness, and there are a lot of training companies, including ours, who provide a lot of these resources online. We also, as I was mentioning, we have a complete knowledge-based platform called Gyaniki, which is giving this complete end-to-end knowledge base with manufacturers, suppliers, components, the technologies being used. And it takes a self-motivated person to understand that these are things that will help them get the job. And uh, right, so there is a lot required to be ready. And they also need to, every student also needs to understand where exactly in this domain, what is interesting to them. What do they know about the electric vehicle at this point, and what is the gaps in the knowledge, right? And then cater to that with some skilling programs. Uh, a lot of colleges are also organizing the skilling programs, and that is how they can proceed. Right. So if we look at what's next in automotive, not just limited to the electric vehicles, but these are the areas of significant work which are happening. So first of all, obviously, electrification is happening, wherein battery electric vehicles are coming, and also fuel cell electric vehicles are coming. Now they are no longer just on paper. The prototypes and initial vehicles are already running in the field, even for fuel cell electric vehicles. Then there is the area of advanced driver assistance features. Lot of work is happening in this area. So if you take the technical centers of Mercedes-Benz or Bosch in India, 50% of the teams are working on features related to advanced driver assistance. Here there is also integration of data science and machine learning. So at least you need to have base knowledge of those elements. Then computers and computer science cannot be kept away. There is a whole ecosystem of shared mobility, which we already know as Ola and Uber and so on. There are multiple app-driven last mile and customized offering solutions, wherein the market is significantly growing and there are a lot of job opportunities in that field. But then those people need to know the electric vehicles, need to understand the data coming from the electric vehicles. Then we have the connected solutions, the Bluetooth, the Wi-Fi, and all the elements required to make a vehicle-to-vehicle communication or vehicle-to-infrastructure communication, vehicle-to-grid communication, right? Just make a vehicle as a talkative human. It's interacting and exchanging data with everything around it. So a lot of work is happening in that area. There is significant work happening in autonomous. Advanced computing is being done on board the vehicle and also on the cloud. Lot of data coming from cameras fitted on the vehicle, based on which the vehicle is taking decisions. So autonomous again should not be thought of only as a on the road. The on the road may be a long ways out in countries like India. But when we talk about robos in a warehouse or automated guided vehicles or what is called as autonomous mobile robos, AMRs, there is a huge market. There is a huge amount of work that is required in this industry, and I will tell you that most students don't even know that there is something called as AMR, right? There is a vehicle called as AMR, right? Which brings into principles the maybe some of the students who may have appeared with or done some work in Robocon and so on. They will see it very quickly because it's building on that. It's a robo which is autonomous with a mind of its own and some part of decision on the cloud and taking material and other things from one place to the other. And then there is a lot of work happening on the manufacturing side, which is called the Industry 4.0, getting to automatic processes or robotic process automation. That is another term, RPA, robotic process automation, and that is also bringing a lot of work. And IoT monitoring, which is required for the Industry 4.0. So overall, from an automotive perspective, the future is clearly that we have the evolution to a computer on wheels. Instead of looking at automotive as a mechanical vehicle, we have to look at it as a computer which is on wheels, and that is where we are moving. Right. So I think I've covered most of my slides. I do want to say that even all through my career, this career, the question I get asked the most, right, and which every time I hear it, even after 10 years of coming back to India, occasionally when I meet someone for the first time, they still ask that. And I feel very sad that this still happens to be the question. And every time I get asked, there's a very sarcastic smile on my face because there's a lot of people asking me why leave US, why come back to India, why do a startup in India, why not be settled in the job and earning very good salaries, which over the 10 years would have grown significantly. And it's not just family, it's not just local opportunities, it's definitely not nationalism, but it is just an answer to home is where the heart is, right? And not just applying it from a location, but also what mindset you are working in. If someone is working in a company where they are not happy with the type of work, they will see the frustration, right? So whether it be home or whether it be work, it should be where the heart is. There is no right answer, there is no wrong answer. Someone may like something and no one else may be able to understand why they like such a job, but it is a person's choice. So home is where the heart is, and I would say work is where the passion is. If you are not working in the area or domain where your passion is, right? It should not be that, oh, now electric vehicle is the growing domain, I should work in that. You have to first test whether you are passionate about it. And if and only if you are passionate about it, you should be entering into it. There is a lot of elements already out there. There are roadmaps, but the companies are not yet in hiring mode because of the situation. They will soon be. In fact, you may not know, a lot of you may not know. And if you not know this, then obviously you don't have enough data sources as well. Ola, which we know as this cab sharing company, Ola is actually putting the largest electric two-wheeler plant in India. And they are claiming it will not just be the largest electric two-wheeler, it will be the largest largest two-wheeler plant in India. And they are going to start launching their two-wheelers, Ola branded two-wheelers, electric two-wheelers, from early next year. So there is so much happening in this domain. Ola Electric Mobility is becoming a OEM. They are becoming a manufacturer. They are going to be the name on the vehicle. And they have just recently put out that they will be adding 2,000 new jobs. 2,000 new jobs. Right? So all these things are happening. But then for these 2,000, there are already 2 million people sitting outside. Right? So that's the demand and supply problem. And this demand and supply problem requires us to take our career in our own hands, to evolve it, to make it visible to everyone, to present papers, to attend forums, to do a lot of things, right? That is what it is going to take, right? So that's all from my side. I know I've not gone into very specific roles about the electric vehicle. I do believe sincerely that people who are interested in it are already following what is happening in the market. They know about companies like Praveg and Ola and a lot of startups that are doing some very good vehicles, as well as companies making motors and battery management systems in India. So that connection has to be done if you are interested, in seeing this as a future career. Okay, so that's all from my side. I am open for questions.
Yeah, Shekhar, there's a question by Dinesh actually.
Yeah.
He's asking how far the involvement of solar technology with EV will help industry.
Which technologies?
Solar. So specifically, he's asking about having solar charging.
Yeah. So there are two elements, right? The first entry of solar will not be directly on the vehicle. It will be integrated with the charger. In fact, one of my friends who recently bought a Tata Nexon EV, he already has a solar system on at his home. And now that solar system is not only giving all the energy for the home, it is also charging the vehicle and returning some portion to the grid. So actually they are making money and also charging for free. Total charge the vehicle there's zero money involved, because the solar system was already there for the home. This is just one additional output that is being taken without incrementing any number of panels. And so solar first integration is going to be at the charging station. Secondly, there is a lot of talk about adding solar panels on the vehicle itself, the roof of the vehicle, and so on. There are prototypes and even concepts that have been made, even with companies like Hyundai. But the overall energy coming out of it today is not contributing more than 5 to 10%. So it's a cost benefit analysis there. But at a charging point or at a charging station, integration with solar is just going to make it very, very cheaper.
Okay, Shekhar, another question was there from a feedback form. Like, what do you think how the cost of manufacturing is reduced in EV segment?
See, cost of manufacturing actually reduces with the scale of manufacturing. That is the rule, first rule, right? And the scale of manufacturing will increase only with the adoption. Now, what is happening? I'll tell you one thing for sure, that the complexity of manufacturing a EV is significantly less than the complexity of manufacturing a engine plus a IC engine vehicle. So overall number of stations shrink by 1/3. So there are 1/3 less stations required for manufacturing a EV. The other thing is, there is a concept coming right now, which is of micro factories. So a EV manufacturer does not need to set up a single large plant, because the component integration is so simple that it can be easily carried out at multiple locations. And the machinery is not that expensive. That means that the same two-wheeler company can run 10 different manufacturing plants across the country, catering to the regional volumes. And that can significantly help reduce the overall, not manufacturing, but manufacturing plus logistics cost in the overall ecosystem. So there is a lot of work happening there. But when it comes to manufacturing four-wheelers, the precision required in an electric vehicle is more. That means the number of robos required is more. And some of these battery packs are 500, 600 kgs heavy. So they cannot be lifted without automation. So those are the things where the cost is going to be added. So I would say two-wheeler manufacturing of a EV is already cheaper, much cheaper than a two-wheeler manufacturing of a conventional vehicle. And with the four-wheeler, it's more of the automation and robos that have to be spent upon. So that's the reason why manufacturing is initial cost very high, but the running cost is very low. And the warranty issues are also much lesser for electric vehicles.
So Prathamesh had that question basically on to cost reduction. I think yes, Shekhar, you are correct, and also localization would also help EV industry to bring down the cost
So,
on the part level.
localization initially will be expensive, right?
Okay.
So localization compared to a China-based component initially will actually add 20% cost, and over time it will
Correct.
reduce, right?
Correct. There's a question again, Shekhar, on what do you think on hybrid EV? Will it be a future? How do you look at it?
The world is going to have all types of systems out there. Hybrids will remain, electric will become significant for some time, and from a four-wheeler and truck perspective, the final resting point is going to be a fuel cell electric vehicle from the vision known right now. So hybrids are going to remain because for personal purchase, they are still the most preferred element. Over time, they will reduce some market share once the EV volumes increase to reduce the battery cost further. But yeah, hybrids are not in the limelight. The work is still going on in hybrids, and product launches are still happening. Europe is also very vocal about hybrids. But right now, what steals the headlines is electric, right? So, but hybrids are there to stay for another 20 years.
Okay. There's again a question by Dinesh on after sales service. What do you think? How do you see the service in comparison with IC engines? How do you think it will be in near future when there will be more EV on road?
Yeah, so when we are talking about an electric vehicle, there will be two types of services required. One element would only require mobile service engineers. So you will never have to go to a dealership. You will never have to take your two-wheeler to a dealership. It is no longer required for an electric vehicle. If you have some issues, you can call the service person. The service person will come at the location and solve it, right? From a four-wheeler, the first level of troubleshooting will happen in this way only. But if there is a more complicated element, then it will have to be taken to a specialized service location, and not every dealer location will be servicing electric vehicle because the specialized equipment, even the dealer is not allowed to today do anything within the battery pack. So then the company takes care of it. Now, over time, the company will allocate where the volume grows significant. The company will allocate one of the dealers or one of the facilities to take care of some of the critical elements also at the same location. But the overall dealership ecosystem, it will have to evolve. We don't know the answer yet of how, but it will have to evolve. It will no longer be that complicated. And since they used to get most of their revenue from sales of parts and service, this revenue is going to be significantly impacted with electric vehicles coming into the picture.
Of course. So, Shekhar, we had one more question by Prathamesh, but it is related to pricing of the current vehicles on road.
Okay.
The current vehicles are too costly to, afford. How do you think it would be in future?
Yeah, so see, that is where I think there are going to be two segments. It's not that electric vehicles are not selling. Right now, they are selling like hotcakes. The latest offering of Tata Motors and MG electric vehicle, even the Kia, they are selling. They are selling well, and there is a market for them. Even at that cost, if someone has a bungalow or their own facility, they compound. They are able to use that effectively, and they can reduce the charging costs. They can do slow charging during the night time. So there is a market, and that market, the upper level of the market, is already now taking electric vehicles. Now, when we talk about electric vehicles trying to replace the bread and butter platform like Maruti Swift, Suzuki Swift, uh, that is not going to happen anytime soon, because today that price point is just the battery cost itself. So even though battery cost is going to reduce over time, we won't see the key elements here. So only the upper end segment and the segment which can derive the most value from reduced operating cost, like the cabs, only they will move to electric. Everyone should not be getting into purchasing an electric right now. And hopefully that is understood by everyone when they do the cost benefit analysis as well.
Correct, Shekhar. Shekhar, we had one more question by Living Solutions, where he has asked the future of MEMS technology on an EV.
Future of
MEMS.
can you spell it out?
So it is MEMS, microelectro mechanical system.
Yeah.
MEMS.
So
Yeah.
see, MEMS is obviously making inroads in a lot of places, and MEMS will also be making inroads into the interiors of the battery pack, because there is a lot of cell to cell or lot of thermal management elements that are coming in. So there is some restriction on the way it can be used, because MEMS has a temperature issue as well. So even though we see that most of the sensors are now getting replaced with the MEMS, some of the sensors still remain, like the temperature sensors still remain the NTCs. But when we talk about all the advanced driver assistance systems, they are all working with MEMS. So all the gyroscopes, all the accelerometers, the GPS elements, they are now starting to work with the MEMS. So the scope of MEMS, regardless of electrification, the scope is very, very significant in the overall automotive electronics.
Yeah, Dinesh, I could see your question on airplanes on EV platform, but yes, I think this session is more on for your career growth, not more onto industry trend. So this is something that can be expected in future, but let's talk more onto something that can help students, I mean you guys, to be in this profession. So is there any other questions? I think there's no other questions. Shekhar, hold on, I can see one more question. Is asking about if you can elaborate a bit about vehicle grid technology. Vehicle to grid technology, Shekhar, that's the question.
Yeah. So vehicle to grid technology basically means that now my vehicle is also active energy producer and energy user. So let's say if I have my vehicle totally charged and I am going to be out of town for the next 10 days. It may make sense for me to use this power somewhere else, transfer this energy to the grid. So I can effectively make my my vehicle act as a charger and transfer this energy to the grid. What benefit I will get is in my electricity billing, I will get a benefit that I've contributed these many units. And then when I need them, I can obviously do that again. So this is where the vehicle to grid is adding a data element to the overall ecosystem, so that every producer or every user of the electricity comes on the same talking terms directly. You don't have to do anything by your hand or by an app. Automatically, it will take care of communicating, syncing, and transferring. So that is what the V2G technology is doing.
Okay, Shekhar, there's one more question on how and what do you think on the charging infrastructure, basically, the growth of charging infrastructure. Will we be able to capture all the remote areas in coming future?
If the vehicle reaches the remote area, the charger will also reach the remote area. Business goes where the demand is. The charger, there is no sense in sending the charger to the remote area before the vehicle goes to the remote area. Very simple. There are enough charger manufacturing companies now who are actively looking at where to put the next charger. And if they see business, they will go there. So charging infrastructure is a very big myth that we have brought out into the minds of the people, that today I've been using, or my team has been using, a couple of electric vehicles for the last 3 months, and we have had no issues with charging. There is a fast charger 2-3 kilometers away, and with slow charging at the home, we can easily do it in the evening hours or night hours. Yeah, all it took us is to make a very long cable to take it to the vehicle, but that is it, right? So we have complicated the thing in our mind. Charging infrastructure will come. There are a lot of good companies doing a lot of good work, and if a rural area or if the interior gets 5 vehicles, the charging station will also reach there. And it doesn't take a lot of time to set up the charging station, and there is no permission required, unlike a petrol pump. In order to get a petrol pump license, it takes like ages of approval. Here there is no such requirement. Anyone owning their own land can put a charging station. No approvals required.
Yes, Shekhar, that was very helpful. I could see no questions from the audience side now. And so let's wind up. And thank you once again, Shekhar, for the time. And just to give your time to this particular session, we hope to see you soon with other topics that can help and benefit students.
Yeah.
So thank you, Shekhar. Thank you. So, Shekhar, if you wish, you can share your. Hello?
Yes,
Yeah.
go ahead.
So from YP Affinity Group, IEEE Pune, I want to thank Shekhar for his time today. And it was really a great and elaborate session. You talked about what are the challenges in the mindsets of people when they think about coming into industry, not just EV, but any industry. So I think you touched a lot of great topics, entrepreneurship, getting into career in someone is really interested in, and then obviously EV industry. So thanks a lot, Shekhar, for covering these topics for us.
Yeah, thank you, Bhaskar. Thanks for having me. Thanks, Dhiraj. Okay. Thank you, everyone.
Thank you, sir.